Good day, everyone. This is Cristine and Vasquez from BSN Math 3B, Group 7. And now I'm going to report the TUKEY test. Did you know when the null hypothesis is rejected using the F test, the researcher may want to know where the difference among the means is? Several procedures has been developed to determine when the significant differences in the means lie after the ANOVA procedure has been performed. Among the most commonly used tests are the Shifei test and the TUKEY test. TUKEY test can also be used after the analysis of variance has been completed to make pairwise comparisons between means when the groups have the same sample size. The symbol for the test value in the TUKEY test is Q. So the formula of TUKEY test is TUKEY test is equal to x sub I minus x sub j all over square root of s squared sub w over n, where x sub I and x sub j are the means of the sample being compared, n is the size of samples, and x squared sub w is within group variance. Note, when the absolute value of Q is greater than the critical value for the TUKEY test, there is significant difference between the two means being compared. Let's try. A researcher wishes to try 3 different techniques to lower the blood pressure of individuals diagnosed with high blood pressure. The subjects are randomly assigned to the 3 groups. The first group takes medication, the second group exercises, and the third group follows a special diet. After 4 weeks, the reduction in each person's blood pressure is recorded. At A is equal to 0.05, test the claim that there is no difference among the means. The data are shown. Use the TUKEY test and test each pair of means to see whether a specific difference exists at A is equal to 0.05. The group of medication has a mean of 10, 12, 9, 15, 13. And x sub 1 is equal to 11.8. The within group variance has a 5.7. The exercise has a mean of 68302, and the mean is equal to 3.8. The group within variance is 10.2, and the group of diet has a mean of 5, 9, 12, 8, 4, and the mean is equal to 7.6. The within group variance is equal to 10.3. For the solution, for x sub 1 versus x sub 2, the formula is Q is equal to x sub 1 minus x sub 2 all over square root of s squared sub w over n. 11.8 minus 3.8 all over square root of 8.73 over 5 is equal to 8 over 1.32. And the answer for x sub 1 versus x sub 2 is 6.06. For x sub 1 versus x sub 3, the formula is Q is equal to x sub 1 minus x sub 3 all over square root of s squared sub w over n. 11.8 minus 7.6 is all over square root of 8.73 over 5 is equal to 4.2 over 1.32. And the answer for x sub 1 versus x sub 3 is 3.18. For x sub 2 versus x sub 3, the formula is q is equal to x sub 2 minus x sub 3 all over square root of s squared sub w over n. 3.8 minus 7.6 all over 8.73 over 5 is equal to negative 3.8 over 1.32. And the answer for the x sub 2 versus x sub 3 is negative 2.88. To find the critical value for TUKEY test, use table N. The number of means K is found in the row at the top, and the degrees of freedom for are found in the left column denoted by V. Since K is equal to 3, TF is equal to 12, and A is equal to 0.705, the critical value is 3.77. Hence, the only Q value that is greater in absolute value than the critical value is the one for the difference between and. The conclusion then is that there is a significant difference in means for medication and exercise. Additionally, there are two different tests that can be used after the ANOVA. Actually, there are several other tests that can be used in additional to SHIFE and TUKEY tests. It is up to the researcher to select the most appropriate test. The SHIFE test is the most general and it can be used when the samples are different sizes. Furthermore, the SHIFE test can be used to make comparisons such as average of x sub 1 and x sub 2 compared with x sub 3. However, the TUKEY test is more powerful than the SHIFE test for making pairwise comparisons for the means. A rule of thumb for pairwise comparison is used to TUKEY test when samples are equal in size and SHIFE test when the samples difference in size. And that's all my report. Thank you.